Hey everyone. In this episode of ITS Now, I am in conversation with Coen Bresser, who is Senior Manager for Innovation and Deployment at ERTICO, ITS Europe. We'll be speaking about the work being undertaken to effectively utilise artificial intelligence in traffic systems and some of the challenges and issues which are being experienced to do this. Anyway, I'm Alastair and this is at ITS Now. Good morning. Thank you so much for taking part in this conversation. As I said, there's a lot of interest around the use of artificial intelligence in traffic systems. I think it's going to be really transformative in so many ways to what we do within the ITS sector. But I think it's really interesting that your role at ERTICO, you are not only looking at innovation and implementation of different technologies, but you're also the co-chair of TMT2. And I wondered if you could just explain some of the core objectives of that initiative and how you think it's going to revolutionize traffic management.
The best way to do that is to look at an example. There are various examples of what can go wrong if you don't do it. Basically, they all show that if there's a traffic jam on a highway and you use a not TM2.0 app, then all the people who are diverted end up in the same schoolyard, for example. So you get the congestion somewhere else. What TM2.0 aims for is to create a cooperation. So that by sharing the intention of traffic management towards the participants that are driving there, that they can take into account what will happen. Not only traffic management towards one service provider, but also the service providers combined. So if you have an Apple, you have a Google, you have a Waze, you have TomToms, you have the Hears. If they all do the things on their own, you will get 6 queues of different service providers at the same place. Whereas if they cooperate, they might be able to spread traffic in a more logical manner, guided for a large part by the intentions and the things that public authorities have, because in the end, the green phase for a traffic light is only influenced by public authority. By creating this cooperation, you can effectively spread traffic over the entire network so that you have the least amount of pain of anything related to traffic. And that's the intention of TM2.0, to create this cooperation, to create the definitions underneath, to create the operational ties, to get the concept in people's minds, to basically allow for better and safer travels.
Yeah, I think there's been a lot of the issues surrounding the sort of independent development of different service offerings because they've come from separate organisations, often organisations that don't have any heritage within the ITS sector, so don't feel any requirements for that interlinking and collaboration with other organisations.
It's even worse, actually, because each service provider wants to have the largest customer base as possible. So that means they're competing. So why would they cooperate if it might help your competitor? But then you're looking into the benefit for an individual versus the benefit for society. And in the end, it's very nicely explained by the Braas paradox. It might be good to check that, how that works. In the end, it means that individual choices for individual benefits might affect the societal benefits greatly, and thus also that for the individual. But that's not per se easily seen by an individual, because you're driving from A to B and you don't see anything else around it. That's what the service providers and the traffic managers, they have that. And what we explain in TM2.0 is the concept of co-opetition. It's a combination of cooperation and competition. Service providers have their own customer base, likely because they have an appeal to that particular customer base, or they offer services to that customer base that the competitors don't. But then still you can cooperate on data sharing, for example.
Yeah.
If you share data with someone else and you get it back, you both have a better view of what's going on. So if you are the only two doing that, you have a benefit regarding your competitors. If you listen to traffic management or state, okay, this road will be closed, stated by the traffic manager, of course, but we will support these and these routes for your travelers. Then your service goes up, basically. And it goes a bit further than the adagium that is held by a lot of these organizations, is that I market that I have the best service and the best routing. Whereas if you use external choices from public authorities, very likely my service is worsened. So the value of my service goes down. But that's actually not the case, because this road will be closed anyway.
Yeah.
If you use it, your service offering goes down, because you'll get that back from your customers. Why didn't you know this in this era?
Yeah, so you're enriching the whole data mix to provide a better outcome for travellers. I think often a lot of the initiatives we carry out, the equipment and systems that we put in, we suffer from the fact that our users, drivers, pedestrians, cyclists or whatever, can only see as far as the next corner or the horizon or whatever, so they don't understand the whole picture, and it's conveying that benefit of what we're doing.
You can extend it slightly on that. Traffic managers can only address the group. They have these matrix signs on top of the road, and formerly a service provider would be able to, if they drive there, their navigation app would say, you need to go to the right, whereas the sign above the road says you need to go to the left. And you can't really explain that if you're not working together. Because it very well might be that for this particular driver in that particular situation, that going right is possible if he needs to take the next exit and gets off. But then those messages do not particularly conflict, because you can explain it. And these conflicting messages cause confusion, and because of this confusion, you get weird driving behavior. People get uncertain, and that reduces safety, increases congestion, those kind of things.
Remember to hit subscribe for ITS now.
Yeah, and it's also
share the way to communicate.
Yes. Unfortunately, when you get those situations as well, it also ends up with a situation where drivers don't trust the messaging they're getting. So we have to be really careful about those sorts of situations. Certainly, I've had that driving around in different places where I'm getting conflicting information, and you don't know whether it's because some of it's no longer topical. The issue has gone, but the sign's still being displayed or the information's still being given. So it's that conflict between that information can really discredit what we're doing. So we have to be really careful, I think, sometimes about making sure things are updated so they are correct.
Yeah, indeed.
So if we're going to be using artificial intelligence, there are obviously some key challenges that we're going to face with this. We're looking to improve traffic congestion and improve mobility, but what do you think the issues are going to be around actually starting that journey?
To start off and make some things clear, AI has been used for over 2 decades in traffic management. So it's not new. It really isn't. The really new thing is the generative AI. And there's actually a huge opportunity there. Before I dive into that, current AI systems are used for object detection or assessing models, seeing what predictions you can get, those kind of things, which is valuable, of course. But if you look at the traffic management part, what you see with creating this loop, the options that traffic managers have increase. And with the increments in technological capabilities of these traffic management systems, the number of options they get to manage the traffic increases. And particularly in the Netherlands, they have the scenario-based traffic management, which basically means you have a traffic jam here. So this set of settings should be enacted at once. But what is also observable is that with these advanced traffic management systems, the number of scenarios explodes to such an extent that there is a limit, that you cannot comprehend the entire set of scenarios anymore.
Yeah.
And that is where AI might play a very interesting role, because they might be able to assess, given this set of scenarios and this traffic situation, I would advise this set of settings to help the operator to make a better informed decision. What we don't expect currently is that these AI decisions will be automatically enacted in certain situations. If you look at the TM2.0 white paper, we particularly state that AI that is allowed to freely operate in the functional space is what we call, so everything on street. And you cannot control that, so freely operating, we should not want that. Any system, so for example, a traffic light that is governed only by an AI system, AI makes mistakes. So that means that at a certain point, based on an AI decision, says, okay, but I have a very large congestion on this artery and on that one as well. Maybe it's a good idea to give them both green. An AI could get that as an output if it is not limited. Now, traffic lights are limited. This is not possible. It is physically wired, not possible to have that in Europe.
Yes.
That in Europe, it's not possible.
Yes.
And you should not want that. To safely operate AI in traffic management, these safeguards are a prerequisite, actually. You cannot do this if you do not, you cannot apply AI if you do not have these prerequisites there. And a very nice example of systems that are currently operating, by the way, is hard shoulder management, where you can drive over your hard shoulder in case of high traffic demand, which is great. But for safety, these are monitored by cameras. That means that you have one operator that needs to check so many cameras. And if you want to have another hard shoulder, you need to have another operator. And there are just not that many people available to do that. They have other things to do as well. What you can do, and what is happening actually, is that you allow an AI with object detection to monitor that. So those systems are really good at seeing something wrong. So they see a car that has malfunctioned on the side of the road, and they can immediately close the lane. They're allowed to automatically close the lane because it increases safety. Opening it, not so much. That's only an operator who is allowed to do so.
Yeah.
And because of that, you guarantee the safety.
Yeah, I think it's interesting. A couple of points you made. You know, we have been using machine learning. We've been using video analytics. You know, so these are all labels around different forms of AI for many years, and I think a lot of what generative AI brings to the piece is the fact that it can actually sift through far more data than an operator could ever do and actually come out with some meaningful decisions. So, and we're going to see increasing amounts of data as new forms of technology come on stream. So it's going to get harder and harder for people to actually comprehend the overall picture. So it's a really useful tool to provide that insight and provide some options for them to make decisions from.
Yeah, indeed. That certainly helps. And one of the powers of AI is to work with situations that have not yet occurred. So you have deterministic systems and you have artificial intelligence systems. Deterministic, you need to figure out everything up front. And if something new pops up, you need to remake your system basically to a certain extent, because there are several ways in which you can cope with that. But what AI is really good at is taking a lot of examples, and based on these examples, you provide the results that you would see in these examples. You do that again to check if the generated output is correct as you expect. And you do that a couple of times to ensure that the model has been trained well enough, which also results then into situations that if you don't have an example, it is able to come with a probable correct answer. And there's a thing to note about AI systems, and they are statistical machines. And a lot of people treat them as if they are based on causality. So I'm getting into the details. You're an electronics engineer, so am I. It's not a causal system. So it's not a if this, then that. That's not the case. It's an if this, then probably this is what you mean.
Yeah.
And this probably this is what you mean automatically highlights the problem. Why we say that the outcome should be limited to ensure the safety. And that's actually what we propose in the white paper as well.
Yeah, I think that's a really important element. So an example that I give quite frequently is that of traffic signal controllers. We see in films like The Italian Job where people take over and do all sorts of things to the traffic signals, whereas actually within the traffic signal cabinet at the side of the road, there are safeguards built into those so that you can't actually cause unsafe situations to occur. And I think having those sort of safeguards within system elements, subsystems, is really important, so that whatever's happening at a higher level, it can't then impose an unsafe situation within those subsystems. And by having an architecture of that type, we bake in the safety element within the operation, but provides the opportunity to have more flexibility overall by using these new tools. I wonder if you can provide some concrete examples of how AI is being used in traffic management projects at the moment.
There are actually also on streets there are applications of AI in products already, but we're also doing it for projects. So I'll split the two of them. Regarding products, what you mainly see is that it's either in object detection, so being AI in cameras,
Yes,
or it is related to modeling. Those are the main things that you see in products. So with AI, it is easier to predict what might happen at a certain distance in time. Those are the main things that we see. What is emerging indeed is the need for scenario management. My expectation is that that's one of the next ones, because that really means generative AI. What you see in the projects is that that's also a bit the case. Usually, for example, in the project that I'm running in EVO Roads, we have a lot of data. And what we want to figure out is what are the key components that lead to an unsafe situation. And you can deduct that, but then you deduct it based on, again, causality. So you see these kind of KPIs, you see where there's an overlap, and you try to figure out how that works. But you could do it also differently by taking the enormous amount of data and taking the accidents that have occurred as an output. You can train an AI model to automatically detect the risk of an accident, basically. And that is related to infrastructure topics, it's related to traffic, it's related to vehicle age, it's related to weather, all kinds of data. The more data you put in, the more aspects of your data come in, the better you're able to predict when it will be an unsafe situation. And there are some very nice examples of an English company, actually, that managed to predict a very unsafe situation of fog on a highway at 4 o'clock in the morning, where no one would be driving at that point in time, except for one or two people. But if those one or two people enter a dense fog, you immediately have a safety risk. And by having this system, it's an English company operating in the States, by the way. By having this system, they actually prevented serious harm, which is a very nice example of how an AI raises an alarm bell. It might be the case that something is not really right here. And then you look at the output. I said, yes, indeed, we need to take action here. And they did. And that very likely resulted in eventually a safe situation. So nothing happened. The thing is, you can't prove that it was the AI. But that's the case for every traffic system,
Yes.
every traffic model. If you intervene and it works, you cannot claim it's the model.
Yes, unfortunately, that is that things disappear. So people wonder, well, there obviously wasn't a problem. The system's not working properly. Yeah.
Actually, it was working. But you can't see it because the problem didn't occur.
Yeah. But yeah, I think it's interesting. There are all sorts of different applications that have been used for a while now. Foreign object detection, in tunnels and things, wrong way driving, incident detection, things like I think some of the more interesting aspects are sort of trajectory mapping for users like cyclists and things as well is interesting because it starts to show how they may not be doing what they should be doing. So it provides us with information around should we be modifying the design of our roads and streets, etc. as well. So there's a lot of different pieces out there at the moment and slowly sort of coming together.
Yeah. Now, what you mentioned is an interesting one because this detection of pedestrians and cyclists, etc., that is a key thing in the systems of automated vehicles. And then you automatically get into ethics a bit because how did you train your model? How can you guarantee that you're complete? What has been seen is that models trained on publicly available videos regarding you have these streams, the dash cams, for example. What has been observed is that the people you see in those cameras, they're a particular ethnic group, basically. If you train your data set on that particular ethnic group, the rest is harder to detect, which raises a problem, basically. So how can you ensure that what you trained it with is right? How did you do that? And how do you ensure that it remains safe? Is it only a camera that you're using, or is it a LiDAR that you're using? Because that's significantly different. There's a very nice video of a comparison of a camera-based car, and a LiDAR-based car.
With a picture of a road in front, across the road, yeah.
Exactly, and that means that if you do not train your system right, your algorithm right, your camera algorithm, you get into problems.
Yes, yeah.
That's actually one of the benefits of the AI. They will claim, how can you guarantee that this is correct?
Yeah, there's all sorts of issues about unconscious bias and even deliberate bias within models and training, the environments within which that initial data sets were collected. Were they within a controlled environment? So is everyone doing what they should be doing? Have they got a particular type of attitude to using the street or roads or whatever? And it can become a problem when people don't do what they should do. It still doesn't mean that we can run them over. We need to protect them. So yeah, there's all sorts of problems with that initial data training.
Yeah, but I have two things to comment there because the alternative, not doing it, is unsafer. the thing is, if you apply this component, it becomes safer in general, but mainly for a certain bias group. Is that a reason to not apply it? And there's no clear answer on that yet. Our statement basically is if you use a component for safety and it increases safety by having this component, you should want to do this. Of course, you should ensure the safety of this particular component itself. You should do that. But not allowing the deployment ensures that the safety remains on a certain level, whereas you could increase safety by applying possibly not fully 100% correct product. But there's a fine line there. How correct should it be?
Yeah.
One of the things I'm advocating for is a certainty level. It's probability. So why not share the probability? The same with generative AI. Very likely, if you get an answer, you might get a probability rating. Okay, I'm 80% confident about this. For example, then you know that you need to research.
Yes, yeah. I wrote an article quite recently about the transparency of the decision making within the AI environment, and how it's really important that for the public they can trust those decisions, and when they're made, there are concerns that there are either financial or other pressures at play that would benefit particular groups in the situation of an incident, and how an AI model is being trained to make a decision whether or not it would choose to save the occupant of the vehicle that they paid a lot of money for that, right, at the expense of other road users or different types of mode users within the transport infrastructure. So I think that transparency piece is something that is really important moving forward.
Yeah, the transparency is actually a requirement for the AI Act for certain levels of risk, which is good because you need to explain why it is possible. And if you need to explain it, then you take a little bit more care in ensuring that it's correct. Regarding the discussion that you said earlier, I find it always valuable to look at the situation when the AI is not there. If I'm driving a very massively expensive car, and I get to choose if I kill myself or the other, well, very likely will do my utmost best not to kill the other, but of course, hardwired in your brain is that you save yourself.
Yes,
and that's not a problem. That's how people work, and it's just a given. So, yeah, if that happens to that car, this car is bought to ensure that you get to A to B safely. Of course, it should not be a decision to kill the other one versus yourself. But if it's not an AI system, the choice would be clear.
Yes, yeah. It's quite an extreme example, but I think it's important for people to understand that. But the attitudes towards these issues differ quite markedly in different territories around the world. So it's important that we're very clear within Europe that these safeguards are actually in place, and that unlike in some other places where those issues aren't at the forefront of our thoughts.
Yeah, definitely.
So if we're using these sorts of systems, really, I think it'd be interesting for people to understand just about how we do improve traffic flow particularly in urban areas. And then we said about it being difficult for people to understand that they've had a benefit from it. So I think it would be interesting to see how we can actually get measurable benefits for people to see how AI is improving traffic flow.
So to explain it. Usually, if you buy something, you get a product, you give them money, right? So that's a transaction. The problem with products for safety is the value lies in the absence of the transaction, so being the accident. So how are you going to monetize something that's not there? It's impossible. You can only do that by looking at trend numbers. So if I applied this, did my total set of potential crashes go down? That's the only way to do that. But to attribute this missed accident to a particular product, then you first need to identify the missed accident. And I'm not aware of any technology that can detect missed accidents. If it would be there, then a whole lot of ITS solutions would be instantly monetizable. And that is a problem that we as an ITS community are facing. A lot of the things we sell or create are targeting the societal value that you cannot monetize. So if you have an excellent service that saves hundreds of lives, if you sell it to 10,000s of people, why would those 10,000 people buy this particular thing if you cannot claim that it is their life that is being saved for that money costs? And it's even more skewed because it's hundreds of people on a population of 100,000s of people. So it basically is risk insurance. And that means that you need to sell this to organizations that can charge society. And that's basically governments. That's the first one that pops into mind. There are others, like insurance companies, and you have mobile network operators, funnily enough, because they span the entire group. You can't do it with OEMs because they only sell cars, for example. So there's a distinct set of organizations that you could task with such a societal benefit monetization, but they need to want that.
Yeah, well, I think a lot of these sort of infrastructure improvements really prerequisite for that is the sort of social values of government and the value it places in these sort of facilities and applications. And certain countries have a far more commercial outlook. Others are far more embracing of concern for their population. So I think in more socially aware countries, we'll see more of these sorts of facilities put into place. But maybe other countries, they're not as bothered about this sort of thing. And again, that goes back to the sorts of values and outlooks of all of these elements. It's a very different situation, I think. So moving forward, TM2, what do you think will be the big developments for you over the next couple of years?
What we see in TM 2.0 is that people start becoming aware of the concept. They start becoming aware of why it is needed. They start becoming aware that it's actually the only way forward to do so. And that is for a large part also because of the partners that we have. We are public-private combination platform. And we have several partners in different areas here. And by this collaboration, we create this understanding. But this should spread out. And what we also see is that we are a group of like-minded people that are really happy to talk about what's going on. What we need is to move towards the deployment of the concept.
Yes.
So the next steps that I would advocate for the entire group is to clarify what the steps are to get there. That would be the first one. To clarify within these steps what is needed. To clarify what the tools are, what the products are, what the standards are that you should use to allow for a manual is a big word, but in the end, for an organization to see, I want to participate in this future way of managing traffic. How can I do that? What can I do as a player in that field? And that means that we need to map the entire set of organizations. There we have a lot of them already available, those kind of learnings, but it's not available in something you can read or something that you can use.
Yeah.
My intention is to move the platform into the direction of deployment and everything that's necessary for that.
Well, I think that's really important. For those who are responsible for implementing and managing systems on the road network, often they're concerned about making the wrong investment decision for equipment and systems. So instead of doing that, they defer it. Okay, there's a lot of fiscal issues in the background as well, lack of money to do that. So it heightens their risk adversity to making the wrong decision as well. So having that sort of background framework would be really helpful to guide road authorities to start making some of those decisions so that the whole capability does move forward. I think OEMs, in a lot of ways, most new vehicles are being produced with a lot of ADAS features, which we're not necessarily making a lot of use of from an ITS perspective. So having the framework in the background gradually developing on the road network and having some guidance for that would be fantastic.
There's a limitation within TM 2.0 that, for example, the car-to-car communication, we're not describing that. It's an open market there.
Yeah.
And there's a religious discussion going on between two competing technologies. There are some expectations on both sides and some ideas and some interests on both sides. And this particular one is very related to anything you invest now. And if the other is chosen, you might have bet on the wrong horse.
Yes.
That is one of the data sources of Team 2.0. For us, this car-to-car is not necessarily the main thing to focus on. The reason is, in the end, you want to avoid a traffic jam. And this car-to-car communication is when you're already in it. If you look at the number of choices that you have as a traveler in your vehicle, it's pretty limited. You can choose if you go left or right, basically meaning a route. And you can choose to how fast you're driving or how slow you're driving. That's basically your choices. It also means if you look at what can you influence there. And from Team 2.0 perspective, if you're on the link, you are lucky. If there's an accident, you just have to bite the bullet. There's nothing you can do. The most effect you can get by ensuring that people do not enter that link anymore at that point in time. So that means longer distance communication.
Yes.
This longer distance communication and the choice means routing. So a very key part of Team 2.0 is ensuring that you get an overview of the problem on street, what's going on. You get an overview of what you expect, so the prediction there. And if you have those, you can calculate basically how many people you need to move off that link. And for some people, choosing that link is the best option. Could be the case if you just need to exit behind the traffic jam. Tough luck, but then you need to be in there. But that means that someone else might be able to get in there.
Yes.
Of course, your network should support this reroute. And in urban areas, that's easier because because you have a denser network, so the choices that you have are bigger, but the frequency goes up.
Yes.
So that's the other challenge there. But for highways, it's slightly different because the density of the network is less. And if you choose, it could have a significant impact on your entire travel. But not choosing might have a greater impact. And the only way to do that, the only ones who can assess that are the ones who have the overview. So for Team 2.0, it is gaining the overview. And up front, ideally, you should discuss or decide on how you will handle a certain situation. Because if it happens, then it is logical to state to that driver, please take a reroute. For you, it takes 2 minutes additional. If you go forward, it'll take you 15 minutes additional. And you're able to give that option. But the choices they have are pretty limited. So that means if you want to influence it from a traffic management perspective, the interaction with navigation and how it is done, how the information is provided, is actually critical.
Remember to hit subscribe for ITS now.
Yeah. So you've talked a lot there about vehicular traffic, but what about improving facilities for active transport users, pedestrians, cyclists, etc.? I think a lot of the time people lose sight of, we are actually trying to promote the use of active transport modes, trying to promote people for all sorts of reasons to choose those over getting in their car. But how can we advantage them in that situation?
Yeah. There's a premises there, and it's people hardly use navigation for walking. They hardly use anything when they walk. So that means they're difficult to influence. For enabling pedestrians, it basically means that you need to get cars out, right? And there are some very interesting use cases. We did it in the context of a project proposal. There was one of the use cases in which you have a train station, and of course you can predict when the train comes in.
Yes.
You also know that if the train is there, a whole lot of people will start to cross the street.
Yes.
So you can choose to not do anything, but you can also choose to reroute those cars on the other side of the train station. And that will increase the safety of those pedestrians without them even knowing it, because they just see no cars, but you won't notice that. Whereas if the cars would be transferred to the wrong side of the train station, you would definitely see it. And those kind of use cases are on the interaction of modalities. And there's actually a very interesting challenge there, because what are the interactions of the modalities? And what is the value of those interactions? How many pedestrians should have a preference over one car, or vice versa? How many cars should have a preference over one pedestrian? What about trucks? So if you have a very old truck, should you give him preference as well? Ideally, yes, because he doesn't give that much emissions, but that is a reason to have an older truck, for example. So what are the values here, and how do you need to balance that? And then you get into the term orchestration, and that is actually uncharted territory, particularly the choices underneath it. Because looking at a choice on an intersection, if you have a public authority over there, he can decide over that intersection, but that means he gets to decide for 10 different car brands, maybe some 5 logistics operators, a whole lot of people. They all have their interests. They all have different systems. They all have a different area where they go. So if you look at it from the other side, if I'm traveling from Barcelona to Berlin, for example, how many different public authorities will I cross?
Yes.
That means I need to put those choices of those organizations in my car, in my navigation system. And how old are their systems? Are they even capable of doing so? And so on. There are so many dimensions related to that particular choice on that intersection. So also for highways, if you go to the left, you end up on a different intersection than the other one. So that mapping of who gets to decide why, how, and when, what, that governance question, it's not solved.
No.
And actually, it is unsolvable. Because if you expand it again with the trip from the car, that means that 20 different organizations are associated with that particular choice. So they're not going to agree.
Yes. Yes. Yes.
So that means that we need to move to some form of distributed decision making to allow for public authorities to influence the traffic at their place, and the other way around for travelers to ensure that their needs are taken into account for all the different sections that you're crossing, basically. And yes, your system should be up to date. Very likely there are old cars that are not up to date.
Yeah.
It's things even worse. So it's
Yeah.
really hard for you.
That whole collaborative piece is a big issue, particularly as per your example about routing off a particular road that may be owned and operated by one authority. They're then putting traffic onto somebody else's road network, and that's a common issue. So yeah, there are a lot of nuanced and faceted issues at play behind the scenes, which, you know, as a driver or as a pedestrian, you're just not aware of at all. And that whole management piece then becomes far more difficult.
Yeah, it is. And that's one of the major challenges that we try to solve within the platform. So how do we cooperate within this group? We have a very nice cycle of how the data goes. And you can make the steps, the technological steps, but that's the easy part. Easy between them. Well, that alone is pretty difficult.
Yeah. Well, I think on that point we'll end there, Coen. But thank you so much for taking time out to have this conversation, and we'll see how things develop over the next couple of years. Okay, thanks.
Thanks for having me.